Hello everyone, my name is Ubaid Faruqi. I'm a senior escalation engineer at Microsoft, and I've been supporting open specifications for several years. Today, I will present about SMB over quick transport and AES-GMAC signing, two new features coming to SMB. So what problem we are trying to solve by SMB over quick? SMB uses TCP port 445. This port is not open in the firewalls. As such, mobile users and cloud users who need to access files on SMB servers on the internet have two options. Either use VPN to connect to their SMB file servers or open port 445 in the firewall. Both of these options require setup. Also, opening port 445 comes with security concerns. With SMB over quick, we are making SMB server access seamless for mobile cloud and hybrid users. SMB over quick details. Microsoft is introducing QUIC as a new transport for SMB. There is no change in the SMB protocol except for a minor enhancement that I will explain later in this presentation. QUIC is secure, fast, and firewall traversing. QUIC uses port 443. Port 443 is open in the firewalls. QUIC transport offers the same SMB goodness to mobile users, cloud users, and hybrid users over internet that they are used to in enterprise intranet without the hassle of VPN or compromising security. QUIC also tunnels every SMB message from the very first negotiate message. This removes the security concern that comes with using NTLM authentication over the internet. Man in the middle cannot sniff authentication payload or file data thanks to TLS 1.3 security built into QUIC. Another design goal was to make SMB over QUIC seamless for users. SMB over QUIC does not require any user training. The user experience is same as using SMB in the intranet. When accessing SMB servers on the internet, QUIC transport is chosen automatically if it is available. Some of you may be wondering what exactly QUIC is. QUIC is an open standard. It offers a faster, new alternative transport choice over TLS on TCP. From the ground up, QUIC is designed with security in mind. TLS is a built-in part of QUIC. QUIC only supports TLS version 1.3. TLS 1.3 allows only the most secure cipher suites available on TLS. QUIC is also quicker than TLS over TCP. The speed of QUIC is attributed to several factors. One of them is that it uses UDP instead of TCP. Use of UDP eliminates problems that TCP has, but at the same time, UDP does not offer features that make TCP a protocol of choice for connection-oriented applications. QUIC provides the features that improve upon those of the TCP. It reduces latency by better congestion control and unambiguous retransmission semantics. Also, TLS version 1.3 reduces the messaging and round trips needed for TLS handshake and session resumption. QUIC is in the process of being standardized by IETF. It is currently a draft standard, but quickly moving towards being an RFC. QUIC is already in wide use by several browsers like Edge, Safari, and Chrome. Information on QUIC is widely available on the internet. If you need more info, please use your favorite search engine. This block diagram shows where QUIC fits into the scheme of things in SMB over QUIC. As you can see in this diagram, QUIC is another choice of transport for SMB. SMB client will choose the transport without user intervention. Please note that QUIC, like TCP and RDMA, is just another transport for SMB. It does not modify SMB, only makes SMB available over the internet securely. As we saw in the picture in the previous slide, The SMB sits on top of the QUIC stack. Most SMB features work as on TCP. Multi-channel and compression are unchanged. SMB signing and/or sealing is turned off by default. This is because QUIC offers signing and sealing as the integral part of its operation. In this diagram, the process of transport selection is shown when QUIC is available as a transport. The user experience remains unchanged. As usual, a user wants to access a file that resides on an SMB server. The SMB client does the name resolution and then it will attempt to connect to both TCP and QUIC, with TCP given a slight head start. Clients does not know beforehand which transport the SMB server supports. The client will use transport that connects first. No user transport selection is needed. This approach offers another advantage. When the same client will access the SMB server on the intranet, TCP will connect first. On the internet, only QUIC will connect. No configuration is required. On the server side, server starts listening on both port 445 and 443. If server receives a connection request on 443, it will find the certificate and will establish connection and start communicating with SMB client. Server can be configured to listen on only TCP or only on QUIC or both. QUIC offers built-in encryption and signing through TLS 1.3. SMB3 offers encryption at SMB layer. When SMB3 is used over QUIC, the question is, would the SMB encryption be used or not? The answer is that SMB over QUIC will not use SMB encryption by default. It is possible to override this behavior, and client can be configured to use SMB encryption in addition to QUIC encryption. This choice comes with a performance penalty, though, as the double encryption and decryption will be performed. QUIC does not offer any option to disable encryption. SMB encryption gets disabled on QUIC seamlessly. The user experience remains the same. When a user connects on TCP to an encrypted server or share, SMB encryption will be used as usual. If the same server and/or share is connected over QUIC, the client will detect that QUIC transport is being utilized. This will result in clients sending a new negotiate context called negotiate transport context. If no configuration changes is made, the client will send this context, indicating to server that it will accept transport layer security and SMB encryption will not be used. If the server is on QUIC transport, it must honor this choice. The resulting SMB message will not use SMB encryption. If a user desires, this default behavior can be modified by configuration option to use SMB encryption over QUIC. A new negotiate context is introduced for SMB over QUIC. It is called SMB2 transport capability context. Negotiate transport capability context is defined in MS SMB2 section 2.2.3.1.5. It contains a flag called SMB2 accept transport level security. The only possible value for this flag is 1. This value indicates that the client will accept transport level security offered by QUIC and that the SMB encryption, if needed on TCP, will not be used. The server must honor this choice if it is connected on QUIC transport. Certificate management. Since QUIC requires TLS 1.3, a certificate must be installed on SMB server for SMB over QUIC to function. Windows does not automatically generate a certificate when SMB over QUIC is enabled on server. An explicit step is needed to obtain a certificate. A certificate can be obtained from a well-known certification authority and installed on SMB server. In a domain environment, a certificate can also be obtained from domain certification authority. A self-signed certificate, while allowed, is not recommended and should only be used for testing purposes. NetUse command is enhanced for SMB over QUIC. A user can force the client to use QUIC by specifying the transport in the NetUse command. This is useful when both TCP and QUIC transports are available, but user wants to use QUIC transport only. When QUIC is connected and server delivers the certificate, client validates the certificate. If certificate validation fails, the client will disconnect. For testing, the user may not have the proper cert installed or is using a self-signed certificate. A skip cert check switch is provided in netuse command to disable the certificate validation. Performance. We did some performance testing on QUIC. It was compared to encrypted SMB over TCP. What we found is that for small size reads, the performance is comparable, but as IO size increases, encrypted SMB over TCP is much faster. The difference is how the encryption-decryption happens. In SMB, the encryption-decryption is performed asynchronously and as such can be spread around on available processors. QUIC, on the other hand, does encryption and decryption synchronously and therefore uses one processor. In this graph, you can see that QUIC throughput levels off much earlier compared to TCP with SMB encryption. I will now present a demo of using SMB over QUIC.
Demo environment here. I have just some files lying around. I'm going to map a drive here, and I've got a VM running inside of Azure, like running as an Azure IaaS VM here in the US West 2 data center. Go ahead and put in some credentials that would ordinarily work just fine against that machine, and try to map a drive to it using Windows Explorer's, drive mapping dialog, which would be using SMB. So I'm attempting to connect, and it's sitting here, and it's not going to be able to connect because it can't use SMB over the internet, not reliably. And so my error experience there is just sort of not very good. It just sort of acted like my password was no good. That's not particularly helpful. So now I've turned on QUIC, and I'm going to map a drive to that same exact machine using those same exact credentials. But now this time, instead of using TCP and SMB to connect over the internet, I'm using QUIC, port 443, to contain all of my SMB traffic, including that authentication against that machine. And you can see on my network capture there, I've already connected. You can see, and Explorer has now mapped the drive and opened it up. And so that exact same machine and my exact same client are now working just fine over the web using SMB with no problems of bumping into port 445 being blocked or firewalls, not allowing SMB traffic to work because I'm entirely encapsulated inside of QUIC UDP traffic. And if I open up a file here, you can see it's actually just working fine. You can see that traffic is moving along using what appears to be UDP. It's entirely encrypted. There's no way to look at this and see any sort of contents of it. But actually, inside of all that is your old favorite SMB2 protocol. You just can't see it because it's not actually on the wire in the raw.
As you saw in this demo, user experience is not changed. Explorer, drive mapping, and file access all work as usual. This concludes our SMB over QUIC deep dive. Next, I will cover AES-GMAC signing. Another new feature coming to SMB is AES-GMAC signing. This feature adds the faster AES-GMAC signing to SMB. In a recent SDC ISNIA IO lab, partners showed a lot of interest in this feature, and some questions were raised. We are in the process of updating the MS-SMB2 document to answer those questions. I will present the details about AES-GMAC signing here that will hopefully answer those questions. Windows 10 version 21H1 and Windows Server 2022 and later will support AES-GMAC signing algorithm. When present, AES-GMAC is the most preferred algorithm to sign the SMB messages. In the SMB signing capabilities negotiate context, AES-GMAC algorithm is negotiated by using the ID 2. To sign the data with AES-GMAC, a key and initialization vector are needed. SMB signing key will be used as the key, and initialization vector is derived from message ID. The structure shown in this picture is used as initialization vector. The size of this struct is 16 bytes. This struct is used in little endian format as initialization vector. The message ID is the message of the message being signed or verified. The value of reserve 1 and reserve 2 is 0. Server to client is 1 for response, 0 for request. Cancel request is 1 if the message is cancel request, otherwise it would be 0. There are a couple of things to note about AES-GMAC signing as implemented on Windows. Windows only utilizes the first 12 bytes of the struct that was shown in the previous slide as knowns. Also, there is no check is made for overflow of knowns by SMB server or client. If you have any questions on SMB over QUIC features, timeline, and release details, please contact netpile@microsoft.com. If you have any follow-up questions on this presentation or on any open specifications, please contact dochelp@microsoft.com. Here are some links to the documents that have product level and protocol level information on SMB over QUIC and SMB AES-GMAC signing. This concludes my presentation. Thanks for attending.